Okay, so in this part, now we're going to get into the sampling since we discussed um, the data part. Okay, so let's talk about sampling. So, sampling is going to be the most important part because you're never really taking a population. You're always going to be taking a sample, which is a subset of your population. And you want to be able to get really good at it. Why? Because it'll give really good results and really good data that we can expand to the population. Okay? So, the first rule of thumb with sampling is a random sample. So you always want to make sure that you are applying random sampling, which is just the process of using chance to select individuals. And a simple random sampling is a little more with technique. So random sampling just says you put a bunch of names in a hat and essentially just pick them out, right? But simple random sampling says, well, no, if you have a simple random sample, then this means that every sample size n has equally likely chances of occurring. And then the list in which we have to select the individuals is called the frame. If we do not have a frame, then we have to use a different sampling method. So we require that if we have a list of all the individuals within the population, so it's like if I put everyone on the roster in this class on a list, that is my frame. And I want to select not the whole list, because that would be a population. I want to do a subset, which would be a sample. And if I choose a technique in which every single person or every single student in that frame has an equal likely chance of being selected, then it would be a simple random sample. If I decided to just put your names in a hat and go and select one, that would just be random sampling. Either way, we just want random sampling. So let's just say we have a study group of 5 students, right? We have Bob, Patricia, and Maria. And 2 of the students must go to the board to demonstrate a homework problem. And so list all possible samples of size 2 without replacement, meaning an individual who is selected is removed from the population and cannot be chosen again. So we just want to see all the combinations of 2 students, right? We could have Bob, Patricia, Mike and Jan. How about Bob and Mike or Bob and Jan? So we're going to go ahead and let's list those out and see how many we get. Let's list all the possibilities. And Patricia. Okay. And then we will have Bob and Mike. And I'll use MI for Mike because we have a Maria. And then we have Bob and Jan. And then Bob and Maria. Okay. So the next one, now we remove Bob. And so we just have Patricia, Mike, Jan, and Maria. So we'll have Patricia and Mike. Patricia and Jan. And Patricia and Maria. Okay, so now we did that. Let's remove Patricia and Bob, and now we have Mike and Jan left, and Mike and Maria. Now let's remove all 3 of those and go with Jan, and then we have only Jan and Maria. So how many do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 possible choices. And don't worry, in chapter 3, we get to know all about choices and permutations and combinations. Okay, so then in that case, how do we select, right? And so the steps for obtaining a simple random sample would be as clean as possible as we can make it. So essentially, we're going to list all the individuals in the population of interest. We're going to number them 1 through n because that's the best way. And then use a random number table, graphing calculator, or statistical software to generate it. So what you want is a random sample generator. And that will be we could do it through Excel, we could do it through our calculator, and we could do it through any SPSS, Minitab. A lot of robust statistical calculators have it. In this case, in our class, we'll go ahead and show you on the calculator. So to do it on the calculator, what you would do is you would identify your number in your population and the number in your sample. And then you could go to the math and place the cursor on probability, and then you'll see number 5 is rand int. And then on the home screen, you're going to put in the population and how many you want to select, and then hit enter as many times as you need. So for example, if we wish to select a sample of 3 out of 30 students, let's use our calculator to show how we would get that. So the first things we want to identify is the number in the population. So how many people do we have to pick from, right? 30. But how many do we want in our subset, in our sample? We want 3. Okay, so let's go ahead and again, you're going to go to math, right? Prob, and then number 5. Okay, and then you're going to put 133 in the calculator for the rand int. Okay, so let's go ahead and do that. Okay, so let's go to our calculator. I have my T84 plus CE up here. And we'll go ahead and go to math, which is right below the alpha button, and go to probability, which is prob right here. So I usually hit the left and then go back. And number 5 is rand int. Let's go ahead and go to number 5. And my lower would be 1. My upper would be my population size, which is 30 in the class. Right? And I want to select only 3. And then it would hit paste so it looks like exactly the way it shows right here. And hit enter. So notice I'm going to select the 29th, the student that is numbered on my paper, the 29th, the 28th, or 5th student. Now if I don't like those numbers, I can hit enter again, and it will give me another random 3 students. And if you feel like you have a lot of M's, and so these are a lot of M's with the last name, you can hit enter again. And 2, 11, 30, that looks like a really good sample too. So you can just select these, hit enter till you select a sample you feel is good. But any of these are simple random samples of 3 from a population of 30 because you're using technology. So I'm going to go ahead and select the random 3 students of 2, 11, and 30. So I'll go ahead and put that on my paper. Okay, and what this means is we will select the students numbered 2, 11, and 30 from the list. We don't know their names, we just put them in numbers, right? And so it's kind of like that's how we get a simple random sample. Okay, so other sampling methods would mean that we have all these other ones because sampling is so crazy when it comes to different types of groups and strategies because there's so many studies out there, so we had to create more types of sampling. So for example, we have stratified sampling is the first one. And stratified sampling just means that we want to divide the population in subgroups and then select certain number of samples from those subgroups. And I always use the idea of political parties, right? And so if I had a sample of 100 people and I wanted to do a simple random sample like we did in the previous example here, we have the chance of every person we select from the calculator could be a Democrat, a Republican, right? And you're like, well, no, I wanted a blend of political party. I wanted independent party, Democratic, Republican. So that's where stratified comes in. Stratified says, okay, well, now take a group of Republicans, take a group of Democrats, or right, and any other political party you want, and then start selecting your sample size from each. Okay, so that would be stratified. Quota sampling is a variation of sampling, and that's when you're just doing the desired quota is met. So we like to take the size of the subgroup in the population to be the same with random sampling and stratified sampling, but quota sampling would be just samples are collected, so that not necessarily the same size, but just grabbing till we get enough of each. Like if we were picking teams for a soccer team and we say, well, we need 9 people here, 9 people here. Okay, I'm just going to collect till I get 9 people. Cluster sampling is where the population is still divided in subgroups, but then the subgroups are selected as the samples. So you don't select different ones from the subgroups, you grab the whole subgroup. So I always use like dorm buildings for cluster, right? So let's just say I have a dorm and I have the buildings next to each other. Here's building 1, building 2, building 3, building 4. Okay, and each of these have about, I don't know, 10 floors or whatever. So then you randomly select a floor, I would say, okay? And so then you say, okay, I'm going to pick the 4th floor. But you don't pick the 4th floor just on one building, you pick the 4th floor on every building. Okay, so you pick the whole floor of students. So again, you're doing the subgrouping, but then you're taking a subgroup of that and grabbing the whole floor, and you're not deviating. You're going to pick the 4th floor from all of them. And that would be cluster, because you're clustering. You're grabbing a cluster sample, right? You're not grabbing individuals. You're grabbing a cluster, right? A subgroup. Systematic sampling is pretty easy. It's like every 4th person that walks in the door, I'm going to survey. Convenient sampling is exactly what it has. It's just convenient. And you only, and the person next to me, how many cookies do you eat a day, you know? Voluntary is if people want to respond. So we can get surveys in the mail a lot, and sometimes you'll fill them out and send it back. Sometimes people won't, right? So there's some sort of, the sampling's okay for convenience, and because we can't always travel around the world. We don't have enough money, right, to do all research across the world. So convenience is always going to be needed, right? And voluntary, well, yeah, I mean, how else are you going to get people to respond if you don't send surveys out? So we need convenient sampling and voluntary, but they're not always the best way either. They're a little flawed too. All right, let's go ahead and just kind of crash course ourselves with these. So let's identify every 4th person in the class was selected. Okay, that has to be systematic, right? A sample was selected to contain 25 men and 35 women. So notice that they were put into groups, right? Just like stratified. But do they have the same number of men and women in each group? No, they just grabbed as many as they needed. So this would be quota. Viewers of a new TV show are asked to vote via the TV show's website. So if we said it's American Idol, go vote, does that mean every single person watching TV is going to go vote? No, who's going to do it? The people who want to, right? So that would be voluntary. A website randomly selects 50 customers to send a satisfaction survey. Great. So a website spits out through their computer system 50 random customers. Isn't that similar to what we just did on the calculator over here? So I put in like a number of customer that says give me, and my n instead of 3 here was going to be 50, and then it sent it. So that would be random sampling. Random sample. Okay, and so the surveys voters in a town. A polling company randomly selects 10 city blocks and interviews everyone who lives on those blocks. So now think about it. They said, okay, here's a block. Here's a whole area of town. Here's 10 city blocks, and let me go ahead and select these 10 people on these 10 blocks, people on these 10 blocks. And so that would be what? So cluster, it would be between cluster sampling, right, where they take the dorm. There's also stratified where we took clusters as well, right? Subgroups. But notice here they took individuals. They took individuals from the groups. They didn't take a cluster from the group. Here, they took like a city, right, a zip code, and they picked 10 blocks and said, I'm going to take everybody from those blocks. So they took the cluster as the sample. And so therefore, that would be a cluster sampling.